Hello everyone, this is Young Forest. This is a series about self-mock technical interview using English. Let's get started. Today, this episode, we will solve the daily problem of LeetCode. Let's start together. So, it's a medium problem, so we think we should solve this within 20 minutes. The title of the problem is very interesting. It's rooting oranges. Let's read the description together. You are given an multiply n grid where each cell can have one of three values: 1, 0, 1, 2, empty, fresh, rotten. Every time, minutes, any fresh orange that is 4 directionally adjacent to a rotten orange become rotten. Return the minimum number of minutes that must absolute until no cell have a fresh orange. If it's impossible, return -1. So the size of the grid is from 0 to 10. I think it's a very easy problem, although its label is a medium. It's a BFS problem, aka a breadth first search. It's a typical algorithm. We use a queue to implement the BFS, and if at the end of search there is still some fresh orange, then we return -1. So let's start. The time complexity of the BFS is big O m as n. It's because we visit each cell at most once. So the time complexity is the size of cells, and the space complexity is I think it's also the size of grid, because we need to add the new level cells into our queue, and in the worst case, we need to there are all the cells inside the queue, so the space complexity is bigger n multiply m. So let's implement this. Because it's very simple, so I want to write the pursuit code. Let's implement it with C++ directly. So we need to declare a queue to record the current level, because we need to store the row index and column index, so we use a pair to do that. and because we can use the grid. Okay, there is a visit array to record which cells we have visited and which one isn't, but we can store it inside the grid, so we save some space. And in the initial, we will declare a variable to record the time. Oh, this is minutes, so let's use that. Current is 0 minutes, and in 0 minutes we should put all the root orange inside our queue. So let's do that. We need to iterate the grid and put our root orange inside our queue. So 2 presents root orange, and need to push that here, and we need to do our BFS search. There is a pattern to do that, so you should remember this, because BFS is a typical algorithm. You will use it often in your real work and interview. So we need to record the current size, and we will retrieve all the other index in the current level, and at the end we will plus the level here. Here we need to and in the 4 directions we can do that. Let me define a array to present the 4 directions. And we will loop the directions. The DR and the DC presents that we need to add the DR into the R and get the next R. So I will make the next R is R plus DR, and the next C is C plus DC, and we should guarantee that is a valid valid side. So and there is a fresh orange, so we can we can progress it. Here we need to mark that as a routen and push the index into the queue. And I think this is the BFS is done, and as last we get the minutes we need to subtract 1 to get the last minutes to last minutes that every orange is routen, because you can think that if all orange is routen at the first day, the minutes is 0, and we run a for loop, and none of fresh orange is found. We plus the minutes to with 1, and it's become 1, but we need to return 0. It's a easy way to verify that here we should return minute or minute subtract 1 or something else. But in some situation, we need to return negative 1. It's a solution where we find some fresh orange. So return negative 1. In some situation, there is a orange that is isomorph with other routen orange. In this situation, those fresh orange won't become root. So we return negative 1, and let me check something missing. We need to get the m, the row number, and the n, which is the column number, because we are sure that the m and n are greater or equal to 1, so I'm confident to do that. If without this condition, we need to check that the length of grid is larger than 0. Otherwise, here we will got a runtime error. So let's run the code. Oops. Okay, something typo. directions is missing. Let's run the exam. All examples are accepted. So let's submit the solution. All run answer. Output. Except here input is a single empty cell. In this situation, why I return -1? Hopes. Yes. Yes. Here we have bug here. If the minutes is 0, we should return 0 instead of return 0 subtract 1, because in this situation there is no orange, no rotten orange, and the queue is empty. We won't end the while loop and plus 1 into the minute. Here the minute is still 0. We have to return 0. Let's submit it again. Yes, success. Congratulations on me. Yeah, I did this about 1 year and 2 years ago. I think this wrong answer is the same as this wrong answer today. Just forget a corner case that there is no rotten orange. So I think we should remember to check the corner case in a interview. It's a big challenge to design your test case and test your code. It's also important in your real work. So you should pay attention to those corner cases in interview. So I think that's my video. So see you tomorrow. Bye bye.